Hello everyone, welcome to Gchem classes. Today we are going to learn NMR. This is the last topic and one student always asking quantum chemistry concept. So tomorrow we will discuss quantum chemistry concept, correct? So today let me finish this spectroscopy because already I have started. So once it is getting completed, tomorrow I will take quantum chemistry. It is not taking much time, okay? After quantum chemistry, we will directly move to the organic chemistry, correct? So in your examination also, first start with inorganic chemistry, then do with physical chemistry, and then directly come to the organic chemistry, okay? So, likewise, I'll also discuss which type of problem you should leave in examination and which type of problem you should taken up for the solving purpose, right? So let me start NMR today, correct? And this is the final in spectroscopy, correct? And again I am saying that this spectroscopic topic, it is not possible to finish in 1 or 2 lecture. So whatever I am taking here, those concepts that is based on your previous year questions they have asked, right? Because they are following some type of pattern, okay? So basically they will ask based on those questions only, those questions concept only, okay? So let me discuss. First we will see the field strength. What is the magnetic field strength? Okay, how we are calculating the delta value, okay, ppm value, that we will see it. So first it will be magnetic field strength, okay. So what is magnetic field strength? Okay, that I am not going to discuss it, that this is in ground level, okay. Maybe 3 electrons are there in ground state, their spin is something different. You have applied some magnetic field, okay, external magnetic field, and then it is like out of these 3, 2 has moved upside and it will be like opposite spin. If it is now, it is showing opposite spin, this value is delta E, okay. So all these things is there here only, okay. So this the basic level I am not going because otherwise it will, lecture will be too lengthy, okay. So just coming here, magnetic field strength, okay, how to find the magnetic field strength, because they will ask question based on this, okay. So magnetic field strength, we can directly say that delta E, okay. What is the value of this? Simply we can say it, just we'll find out the magnetic field strength. So delta E equal to h nu, okay, that we know already, right? For this nu, we have a new type of formula for this nuclear magnetic resonance spectroscopy, correct? So what is this new type of formula for this new? We'll see it. That will be based on gyromagnetic radiation, correct? It will be H, and then here it will be gyromagnetic radiation, then 2 pi, and then 0. So in this, what is this one? This gamma type of symbol, it is there. This is we called gyromagnetic ratio, okay. And then this one is called applied magnetic field or magnetic field strength, we can say. So we can simply write applied magnetic field, okay. This is applied magnetic field, or we can say this is only your magnetic field strength. So based on this, this is only magnetic field strength, right? How much applied magnetic field you are applying to that that spin, that molecule will have their own electron, right? And it is spinning in own axis, like Earth, correct? Earth is spinning in own axis, and then it is spinning towards, like circulating towards like around the sun, correct? Likewise here also it is happening, correct? So applied magnetic field. Now with this formula we will solve, there are many questions, okay, we will solve it. So this is one formula, okay. And then this already they have asked in examination. One more formula I am going to discuss that they have not asked, but maybe in upcoming examination they might be asking, that is the chemical shift value. How to calculate the chemical shift value, okay, means delta ppm, okay. So this is in ppm, how they are calculating, okay. They will, for this type of question, they will give you the instrument's frequency, okay. Suppose they are telling that instrument frequency is 300 megahertz, okay, 300 megahertz. If they are selling that their instrument frequency is 300 megahertz, and whatever, how much, like from the TMS, the question will be like this: instrument frequency is 300 megahertz, and the frequency, like distance from the TMS. What is TMS? I am just going to say it. Distance from TMS is 600 hertz, So what will be the delta value for this? Okay, delta we are finding the chemical shift value. Based on that we say that this is the compound. Okay, if this type of question they are asking the frequency of instrument. Okay, frequency of instrument, maybe it is 60 megahertz, it can be 100 megahertz, it can be 300 megahertz, it can be 400 megahertz, it can be 800 megahertz, correct? So you have to see 300 megahertz means it will be 300 into 10 to the power 6 hertz, correct? And they are saying that from TMS the first peak is coming and they are coming on 600 hertz. Okay, so how to find this delta value? So we know that delta formula is, I'll just write up here itself. I'll just rub it 1 minute. So the formula is delta, the observed shift from TMS in hertz. Okay, in hertz you have to write operating frequency of the spectrometer where you are measuring, right, spectrometer in hertz into 10 to the power 6. So now see, you have all the values, right? Observed shift from TMS is 600 hertz. So 600 divided by operating frequency of the spectrometer is in hertz. So operating frequency is 300 megahertz, right? It means 300 into 10 to the power 6. So 300 into 10 to the power 6 into, you have 10 to the power 6. This will get cancel it out. This will cancel it out. 3 into 2. So your peak distance will be 2 ppm. Okay, 2 ppm, part per million, correct? It means we'll directly draw the shift, like the range. It will start from 0 and it will reach till 14. Okay, so now this particular question, your peak will come, suppose this is 1, this is 2. Okay, so this is 2 ppm, this is 1 ppm. So your peak will come here. Okay, like this, one singlet, it will come here. And 0, this is for TMS. Okay, TMS. What is TMS? Tetramethylsilane. Okay, this structure will be like CH3, 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 CH3. Okay, tetramethylsilane. And why it is coming in 0? Because this solvent only we are taking. Why this compound is coming in 0? Because this is also electron releasing group, this is also electron releasing group, here also it is electron releasing group, here also it is electron releasing group. Okay, if we have electron density more, okay, if we have electron density more, then what will happen? This peak will be in upfield. Okay, this side we call upfield and this side we call downfield. Okay, suppose we have CH3, just I'll compare CH3 fluoride, CH3 bromide, CH3 chloride. Okay, so how it will come? So if you don't remember the value, delta value, no problem, just compare it. See, this is more electronegative, it will pull more density towards fluorine. Okay, it will pull lesser than fluorine. It will also pull lesser than fluorine but more than bromine. So your delta value will be somewhere for this CH3F, it will be more downfield than this one, and then finally this will be in upfield. Okay, so if we are just arranging here, CH3F somewhere it will come here, CH3Br somewhere it will come here, CH3Cl, and CH3Br somewhere it will come here. Okay, it means the delta value will be more for CH3F, okay, because it is in downfield. So it is in a simpler line. If more electronegative element is attached to the carbon, and in that carbon if proton are there, that proton will feel their electron density, lesser electron density, and then it will move towards the downfield. Okay, so based on that you have to calculate. So some value I will tell, after that I will start solving. Okay, I am having some values that will be important for your upcoming examination. So don't go and see that NMR there are many values, so I have to mug up everything. It won't be like that. I'll just give you some of the values. Based on that all the problem will get solved. Okay, whatever problem in NMR it will be solving. Okay, and for you, they won't ask you much difficult question or something. Simply they'll ask basic things. Okay, so just I'll write the values. This much values is enough for you, okay, for this upcoming examination. So suppose normal CS3 is there. This CS3 means suppose it is a ethane, okay. So if directly it is attached to carbon and this carbon is sp3, okay, that you have to see. If this carbon is sp3 and here it is, this CS3 is attached, so your value will be 0.9, okay. This is the delta value in ppm. That is scale is there, no? 0 to 10. In this scale, it will be in 0.9 somewhere here, okay. One peak it will be show. Then next value I'll write if it is acetone type of thing, okay. Suppose beside that carbonyl is there and then next carbon we have hydrogen. This hydrogen, it will feel the value will be around 2.1, okay, around 2.1. So somewhere suppose this is 1, this is 2, so that peak will come here, okay, 2.1, okay. Next will be your aromatics. Suppose it is attached to the aromatic compound, this CS3, like toluene, okay. So toluene, for toluene this value will be 2.3. This will help you out. So these are not the fixed value, okay. It will just relative value, okay, and relative to TMS, okay. TMS always it will be in 0 and based on that we are measuring the shift, correct. And then if it is with bromine, it will be 2.7. If it is with chlorine, then it will be somewhere to 3.1. If it is with fluorine, then it will be 4.26. See the difference? With fluorine 4.26, with chlorine 3.1, with bromine 2.7. Just to compare the thing, okay. And 2-3 times you just practice it. It will be like whatever problem you have with NMR, no, just practice those problems itself with these values. It will be easy for you, right? And now, if it is attached, whether it's esteric O or if it is etheric O, etheric oxygen, what will happen? What will be the value? 3.3, correct? And then aromatic itself, they will have one proton, right? Enter this aromatic. Suppose this is a benzene ring. So in this benzene ring, we have this hydrogen, right? So these hydrogens value, it will be range from 6.5 to 7.5. If anything is coming between 6.5 and 7.5, just think it is from organic aromatic one, correct? And then aldehydic proton you have to see. It will be around 10, okay. Even acidic proton also it will go beyond 10. It will be 12 or 13, okay. So likewise, this much value is required for you, and with this value you can solve it easily. So if you want to take a screenshot, you can take it, correct? Done. So we will just find magnetic equivalent. What is magnetic equivalent? And then we will start solving the questions. It will be very much important. Suppose here it is CS3 and here it is NO2. Okay, 2-3 example. Just I'll write it down, and then just we will find magnetic equivalent. Okay, if you are able to find out the magnetic equivalent, you will be able to solve the questions, okay, problems. This is one compound, this is another compound, okay, CS3, I'll just write this is A, and then CS3, NO2, this is B, and this 3 only you solve it, okay. So how many type of magnetic equivalent means how many type of protons are present. For this compound, how many type of protons are present. For this compound, how many type of proton are present. For this compound, how many types of protons are present. You just comment it, okay. You just comment it. I'll see whether it is like you are going in right direction or not. And we are talking about proton NMR. Okay, we are talking about proton NMR. Tell me how many type of protons are present in A, how many types of protons are present in B, how many types of protons are present in C. That we call it magnetic equivalent proton. Okay, what we call magnetic equivalent proton. Okay, in questions they might ask how many magnetic equivalent protons are there. So don't get confused. It is directly how many type of protons it will be expected. Okay. So you just tell me how many type of protons are expected. Then I'll tell you that the doublet, triplet, singlet, multiplet, how it is coming. That also I'll explain with the examples, okay, where the examples are there, PYQs. Based on that I'll solve it. Maybe you are giving answer. So for this you just see A. Here also it will be A only, because if you are passing a plane here, these two are reflecting each other, correct? And these two are the equivalent thing, okay? A. Here one proton are there. So protons, we'll just write it down where the protons are. Here proton won't be there, okay? So now you see this one will be B, and with this mirror, if it is reflecting, this will be also B, and you put one more mirror here. This one is also reflecting here. This one is also reflecting here, okay? So this will be also B, and here also this will be also B. So here two types of protons are there, or magnetic equivalent protons are there. For this complex, we'll see it. Let's see. This will be A, this CH3, and then protons, just I'll draw it out, all the proton, and we'll see. Here for this it is ortho, for nitro also this is ortho, so this is a B type, and for this proton, from nitro it is ortho, and from toluene it is para, okay? So this we call it C type, and then for this proton, from nitro it is meta, and from what is that, CH3 it is meta, okay? For both it is meta, but we don't have this kind of proton, and like this is ortho, but this is meta, okay? So magnetic equivalence is getting changed, so this will be D types, and this will be your F type. So how many are there? 1, 2, 3, 4, 5. So 5 type of protons are present in here, or magnetic equivalent protons are present here. A, then just I'll draw out. This will be your B, here also it will be B, this will be C, this one will be C, okay? These are the similar thing. How? Just you put one mirror here, okay? This one is reflecting here, this one is reflecting here, so it will be same. But if you are putting mirror here, this won't reflect this, okay? If these two are not equivalent, then these two won't be equivalent, correct? So that's why this is A, this is B, this is C. 3 types of protons are present. So these 3 examples are very much important for you, and then directly we'll take up the questions from the PYQs and we will solve there itself, correct? So let me take one by one the questions. First question I'll take it from 2022, the question number 12. Okay, you can see in the screen. Okay, so question number 12. Any compound having molecular formula C9H10O2 exhibits, I'll just write C9H10O2 exhibits the following spectral characteristic. For NMR they have given IR, okay, IR 1720. It means somewhere it is carbonyl is present, okay, like this it is present, okay, and 1720 means it's a esteric one, so there will be a steric kind of link will be there. Suppose you are telling that okay, IR that much we are not learned, so leave it. If you don't learn, you leave it this one, okay? Just this much you know, right? For 1721 carbonyl will be there. If that much also you are knowing, your problem will getting solved here, okay? So now you just see for proton NMR, one in 9.72, okay, 9.72 it is triplet, okay? So 9.72 and it is giving triplet for one proton. So this value I'll tell. So any one example I'll take. Okay. Suppose one example I'm taking. Any one example I'm taking. Or what I'll do, based on this data, I'll try to draw the structure. Okay. We know that one carbonyl will be there. So just we are drawing one carbonyl. Okay. And then proton NMR, one triplet is there. That is in for single proton, okay? If we are giving proton here, but it won't be give triplet, it will give singlet, okay? So we need triplet kind of thing. How it is giving singlet, I'll just tell you. If this type of proton we are drawing, then only it will give triplet. See, whether it's giving triplet or singlet or doublet, how it is coming? See, if you are calculating for this proton, suppose you are calculating for this proton, so the next carbon is this one, okay? This proton is attached to this carbon, so next neighbor carbon is this one. So in neighbor, how many proton are there? So that n+1 value will be your singlet, doublet or triplet. Suppose this proton, this neighbor is having 2 proton, correct? So for this proton, how many like singlet, how many multiplets will become? So it will be n equal to 2 plus 1. So how much it is coming? 3. 3 means it is triplet. But in this case, you just see its neighbor carbon is this, and in this carbon there is no hydrogen. Okay, if it is not, if it is not having any hydrogen, what will happen? N plus 1. So n equal to 0 plus 1. Okay, it means 1. So it will give singlet. That's why I told it is giving singlet. But in your question, it has given it should give triplet. If it is giving triplet, then this type of structure it will be possible. So both, like in option you see this type of structure where one CH2 is attached to the aromatic and one side it is attached to the carbonyl. So option A will be eliminated out. Option B will also eliminate out. Option C and option D. Okay, either of these two will be your answer. So let's see. Next, first 9.72 is done. Now 7.11 doublet and 6.71 doublet. So I'll just write 7.11 doublet it is giving and 6.71 doublet it is giving, and this is for 2 hydrogen and this is also for 2 hydrogen, correct? Now you see, I told you 6.5 to 7.5 it is for aromatic. So in aromatic it is telling that 2 types of protons are there. Okay, 2 types of protons. That means if you are drawing these protons, so the next functional group will be attached here itself. Okay, it will be attached here. It can't attached here. If you are attaching here, then what will happen? 1, 2, 3, 4 types of proton will be there. Okay, if you are attaching here, then it will be like 1, 1, 2, 2. So 2 types of protons. So now you just see option C is having O methoxy here, and option D is having in this place. Okay, so if it is in this place, then 1, 2, 3, 4 types of protons will be there for aromatic. But here it is saying that a 7.11 doublet and 6.71 doublet is there. So only 2 types of magnetic equivalent protons are there. So your structure option C will be correct, but we will not stop here. We'll solve everything. Okay, and then we'll go to the 3.8 one singlet that is giving 3.8. Okay, 3.8 it is giving singlet, and that is for 3 hydrogen. Okay, so for 3, see here this one is CS3, right? CS3. For this carbon nearby is like neighbor is oxygen. Okay, so there will be no proton. So no proton means n equal to 0. So now n plus 1. So 0 plus 1 it will be 1. 1 means it will give singlet. So this one is giving singlet, and directly it is attached to oxygen. So 3.8. Okay, I told you I already gave you the values, correct? So directly attached to oxygen it will be 3.3. Okay, but here it is attaching to aromatic, so maybe more downfield it has came. So 3.8, this is also giving 3.8, correct? And singlet also. Next, 3.6 doublet for 2 hydrogen. Okay, 3.6 doublet for 2 hydrogen. See, for this particular proton, what will be the multiplets? Just n plus 2 rule you just follow, n plus 1 rule you just follow it. N, the neighbor carbon is this one. Here also one neighbor carbon is there. For this side 0 proton is there. For this side, see, 1 proton is there. Okay, so n plus 1, 1 plus 1, so 2. So it will give doublet. Okay, this one is giving doublet, and this value is in 3.6. Okay, because one side is carbonyl, another side is aromatic. So it is going directly to the 3.6. So this value is not at all required, correct? Only for whether it is a carbonyl or not, for that purpose we need that one. So now you have already solved. Your option C will be your correct option, right? So question number 12 is already over. Now question number 43 we have for the same year. Question number 43. If you still have doubt, you can ask me. Okay, these are the very simple question they are asking. NMR means it will be very simple question. Okay, question number 43. Okay, magnetic equivalent proton they have asked. You will only solve it. As I will draw it in board, I know you will be solve it immediately. So question number 43. Let me draw first. Okay, don't answer it. Let me draw first. I know the answer started coming. Okay, here one CS3, here one CS3, CS3. Now you try to draw how many. The question is the number of signals observed in proton NMR spectrum of the compound, means how many equivalent protons are there. Let's see how many equivalent protons are there. First we'll see if you are passing a mirror from this place, this one is reflecting here, this one is reflecting here, this one is also reflecting here. So whatever type of proton will be there, 1, this will also 1. Okay, whatever type of proton will be there here, 2, because this is proton, right? This is proton. This is also reflecting here, right? So this will be also type 2. Whatever proton is reflecting here, the same will be here. If it is, this is 3 types, this will be also 3. Now you just see whether you are writing 4 here, 5 here. Let's see. Before writing, just wait, just pass one more mirror from this side. So see, exactly reflecting. This one is reflecting this one is reflecting, this one is reflecting, and this one is also reflecting. So if it is this, if this one is 2, so this proton's environment will also will be 2. If this is 2, see, this one will be also 2. And here also you can see, if this one is 2, this will be also 2. So see, it is completely reflecting each other's, correct? Now this is 3, so this will reflect as a 3, or you can say this one will also be a 3. Okay, so 3 types of proton we are seeing here. So your answer will be 3. Okay, you just write it down, answer 3. Your answer will be correct. So next question will be from 2021, question number 7. Okay, we'll see question number 7, what they are asking. 2021, question number 7. Okay, let's see. A compound shows an NMR peak at proton NMR peak at delta value in ppm 7.312 proton. So 7.31, it is in between 6.5 to 7.5, means it is aromatic. Okay, so aromatic it is saying. So if they are saying aromatic, we'll just draw it aromatic first of all. And how many type of protons are there in aromatic? Based on that, just we'll put the functional group. Okay, so 7.312 proton and 7.212 proton. Only 2 type of proton it is having. So one group will be here, another group will be here for sure. Okay, this is proton. So based on data, you just try to draw a rough structures. Okay, see, this is one type, this will be also one type, this will be second type, this will be second type. Okay, so 2 type of proton you already got it. Now 4.5 2 proton and 2.3 and 3 proton. Okay, 2.33 proton. So in our value, for with aromatic, if it is attached, so what will be the value? 2.3, right? So aromatic, directly aromatic, one group is attaching, so just we will write it down here. This will be CH3, so this value will be 2.3, and this is for 3 proton they are saying. Okay, 3 proton. So already we have 3 proton, and 4.5 for 2 proton. Okay, 4.5 for 2 proton. So this one will be CH2. Okay, for 2 proton, and with this CH2 something will be attached. Okay, so now first of all, let's see this type of arrangement where it is. So option A, it won't be. Option B might be. Option C, it won't be. Option D, see, this CH3 is already we have attached, right? For 2.3 it is with aromatic. Okay, with that value. So now option D is also your not your answer. Option B will be your correct answer, because chlorine they are attaching here, and that value is in 4.5. Okay, because one side is aromatic and another side is chlorine, that's why the value is shifted towards the 4.5. So your option B will be your correct answer. If you have doubt, you can ask me again. Okay, so this is from question year 2021. Whether we have another question? No. From 2020 we have question number 35. Okay, 2020 we have question number 35. Let me solve this one. NMR question will be very much easy. Okay, that's why I have taken in last, but you will sure shot get 1 or 2 questions from NMR. So it has given the boron adducts which shows 3 signals. Just will write it down, 3 signals. Okay, always try to decode the questions. Okay, always try to decode the question, how whatever, because they will give you paper and pen, right? First line you read it, something you write it down. Second line you read it, something you write it down. Okay, so the clue will be there for answering those questions. The clue will be given in question itself, correct? The boron adducts which shows 3 signals in proton NMR spectrum with the intensity ratio. They have given intensity ratio is to 3. It means the integration value, how much for first one, how much for, suppose for this, if these are the peak, okay, delta value. if it is delta value. So if one peak is coming this much height, another peak will be this much height, and the third one will be this much height. So this, what is this peak intensity it is showing? It is showing the number of proton will be in this ratio. It means number of proton will be in this ratio, correct? 1:2:3. Okay. So now you have to see, so for this type of question you have to start from question number A. Okay. Just try to draw CH3. I'll just open up, okay, boron, and then CH3, 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 and then here we have nitrogen, here also CH3, CH3, CH3. Okay, so in this type of proton, what we'll see, it won't be 3 signals, it will be 2 signal only. You see A, this will be B, B, B. This environment and this environment is same, and this environment is also same. So this 3 will be one type, this 3 will be another type. So how many? 3, 3, 3, 9 is to 3, 3, 3, 9. It means 1:1. So this won't be your answer. First of all, it is having only 2 signal. Okay, question number A, it will having 2 signals, and that also ratio is 1:1. Okay, so option A won't be correct. So let me draw option B, because we need 3 signals and with that ratio, correct? Option B, if we are getting, so it is, this also I'll open up. So boron, here it will be CH2 and CH3, here will be CH2 and CH3, 3 are there, yes, CH2 and CH3, and this side nitrogen, here also, okay, CH2, CH3, CH2, CH3, CH2, CH3. Now you just see it. This one will be one proton, this one will be another proton. So 1, 2, these 2 will be equivalent, 1, 2, these 2 will be equivalent. Here these 2 will be equivalent, 1, this is 2. So this is one type, this is, I'll just write down 1 AB, okay, 1 or 2, maybe you will be get confused that 1 proton or 2 proton. So AB, AB. Here this side, it will be, here also we can see it, it will be suppose C, okay. Okay, C, this is D, this is C, this is D, this is C, this is D. So C or C equivalent, C or C equivalent, okay, D or D equivalent. So now you just see there are 4 types of signals is present, and this, out of this 4 type of signal, we need 3 type of signals. So and here it is 4 type of signal, but ratio also we will calculate, okay. So for A type, 2, 2, 2, so total 6 proton, is to B type 3, 3, 3, okay, so 9 is to here, C type is 2, 2, 2, 6 is to D is 3, 3, 3, so 9. So just make it simplest one. So 3, 2, 3, 2, 3. So it will be 2:3:2:3. Okay. So the ratio is also not fulfilling. First of all, this signal, number of signal is itself is not fulfilling. Why I am doing, I know which one is the answer, okay, but why I am doing all these things? So in future, maybe they are asking some twisting of the questions, you can able to solve it, okay, that's why I am doing. So now option B is also not correct answers. Let me see option C. Okay, why I am rubbing this one? This is we already know, right? 3 signal. Okay, now option C. Option C also I'll open up directly. First they are given with nitrogen, no, with boron only they have given. Okay, 3 hydrogen, 1, 2, 3, and with nitrogen, okay, CH2, CH3, CH2, CH3, CH2, CH3. See, these 3 will be equivalent. So A, one type of proton. Here you see, these 3 will be equivalent, B, B, B. These 3 will be equivalent, C, C, C. So 3 type of signals are present. Okay, first one is fulfilling. Second one we'll see it. So this one 1, 2, 3. So write it 3. Then this is B, B, B. So how many? 2, 2, 2, 6. This one 3, 3, 3, 9. So just do the simplest one. So 3, 1 ja 3 divided by 3, 2 ja 6 divided by 3, 3 ja 9. So 1:2:3 and 3 signals. So option C will be your correct answer. Okay. Now we'll see option D also, what is happening with option D. We'll try to solve for option D. Okay, always don't try to get your answer first. Okay, try to solve for all the options, because maybe, because this is MSQ type of question, right? Question number 35 is MSQ type of question. So for this, now this side it has shift CH2 CH3, then CH2 CH3, then CH2 CH3, now with nitrogen, proton, proton and proton. So now you just see, this will be A type, A type, A type, this will be B type, B type, B type, this is C type. Okay, so 3 signals are present. Yes, present. Ratio, so first see the B types, it is 9:, C type 6:, B type, and then C type it is 3. So it will be 3:2:1. So again 1:2:3 we are getting. So option D is also correct. So option C and option D will be your correct answer for this particular question. Okay, now question number, it is 2020, question number 38. So question number 38. The compounds which will have only 2 signals, okay, only 2 signals in the proton NMR spectrum in 3:2 ratio. Okay, 3:2 ratio is R. Okay, all the examples you have to solve it one by one. So first, fatafat we'll solve it. Okay, it won't take much time. So this is aromatic. I'll just draw it first. You also try to solve it. I think you will be getting the answer, but I don't want answer. You just tell me how many type of signals and what is the ratio for all the compound. For all the compound, you just tell me what will be the ratio and how many type of signals are present for A, B, C. For all, you just tell me. Okay, it will be a nice practice because you were searching examples, right? So these are the best examples. And NMR, you should get the answer correctly, because these are the free marks you are getting. If NMR question arrives, your marks will be free, right? Now for all we have to calculate, right? Suppose, see, this is CS3, this is CS3. So if you are writing, see, just you have to see the mirror is passing, right? So this is A type, this is A type. Reflecting, right? Completely reflecting. This is proton, here also proton, here also proton. This is B type, this is B type, this is C, this is C. So A, B, C, 3 type of protons are there, but we need 3 signals, okay? Means 2 type of protons we need, but here 3 signals we are getting. The ratio will be, A will be 6:2:2. It means 3:1:1 ratio you are getting for A. Okay, here we'll see whether any mirror is passing. Yes, it is passing. This one is reflecting, this one is reflecting. Everything is reflecting. Let's see. So this will be A, this will be B, and this one will be alone C. So 3 type of signals are there, but we want 2 types of signal. Ratio, it will be 3:6:2:1. So 6:2:1. Okay, and here we got 6:2:2. Okay, this is C, right? And okay, here it will be 4 types of proton. Here one proton is there. No, this will be D type. Okay, this is something different. So here it is not 3 types. It will be 4 types of signals will be there, and 6:2:1:1. This will be the ratio. And option C will see it. So this will be, because if you are passing mirror from here, A, and this is A, right? Now for this proton we'll see, this will be B. So again, if you are passing a mirror, these 2 are reflecting, so this will be also B. And with this mirror, this B will come here. With this mirror, this B will come here. So A and B. So 2 type of signals are there. Okay, they want 2 type of signal, but ratio we have to see. With A to A, it will be 6:2, because 3, 3, 6, and now 1, 2, 2, 3, 4. 6:4. It means 3:2 we are getting, right? So 3:2. So option C will be your correct answer, and this is 38. So MSQ type of question. Question number D will see. If you are this is A, so this will be also A. If you are passing a mirror here, okay, this 2 is reflecting. So here it will be CH2, here also CH2. So this, if you are writing B, then this will be also B. So here also 2 type of signals is there. Okay, and what will be the ratio? These 2 will be 6:2, this 2 will be 2:4. It means 3:2. Here also 3:2. So option C and option D will be your correct answer. Okay. And from 2020, we won't have any other questions. Directly we'll go to 2019. Okay. Number 25 from 2019, right? We'll solve it. Okay, see the question. This is very good question. With acetylene it has compared, right? So one more value you will get to know with acetylene how it is working, correct? So in proton NMR spectrum of the given molecule, the correct order of chemical shift of the labeled proton, okay, labeled proton. So this molecule, if you are drawing, so it is saying this one is H, the proton labeled with Z, and here CH2, the proton is labeled with HY and HY, okay, and then oxygen, and then here it is CH3, and these protons are labeled with X, okay. Now they are saying that based on this, which order of the chemical shift, so delta value, which one will be higher and which one will be lower, okay. So we know that with the oxygen, this value is coming around, we have the value, right, it is coming around 3.3, okay, and for this CH2 what is happening, this is attached to this oxygen, okay. So here also the values approximately it should be 3.3, but here this side with this acetylene it is attached, so here also it will pull. So what will happen, this value will be again downfilled than this 3.3. so if you are comparing, the Hx will be lesser than this Hy, correct, it will be like this. Now you have to see this Z, okay. So now you see that with this Z and this CH2Y, okay, this will be more because it is attached to the oxygen, but in this place this is only attached with this acetylene, this electron cloud, right. So this will be again lesser than this CH3, so we can write as Z. So which option will be correct? See, option D, it is written, it is in this direction they have written, no problem, HY, and then proton is labeled with X, and then proton is labeled with Z, okay. So the same thing, right, we have just written differently. So option D will be your correct answer. This is question number 25, okay, from 2019. So is there any other questions in 2019? Okay, question number 44. Question number 44. Yeah, we got it. So this is one problem, okay. So that already we have given that formula, right, initially. But the second formula what we have given you, that delta value, calculation of delta value, that they have not asked. So might be they are asking with that formula, okay, the delta ppm, how much it will come, okay. So question number 44 in 2019, the magnetic field strength required. So they require magnetic field strength, means H0 they want. Excited an isolated proton to its higher spin state, means suppose here one electron is there and they want to excite it to this place, okay. This value they have given, delta E, might be they have given, just I'm drawing this problem with pictorial thing, okay. They want from here to here, okay. So for that, this applied magnetic field, how much it is required, that they are asking, okay. Field strength required to excite an isolated proton to its higher spin state with an electromagnetic radiation, okay. They have given, how much they have given, 300 megahertz. It means 300 into 10 to the power 6 hertz, okay, is given. So okay, okay, round off to the 2 decimal place, okay. Then magnetogyric ratio or gyromagnetic ratio, this they have given, how much, 26.75 into 10 to the power 7 Tesla per second, okay, that they have given. So now just put these values and you will get your answer, okay. So now we already know for this type of formula, E equal to delta E equal to H nu, and for this nu we have to find it out, what is the value of this nu, okay. This is not, this is delta E, whatever is given, it is in hertz, so this is directly they are giving this nu value, okay. So directly don't calculate for the energy, delta energy, it is like the whatever the nu frequency multiply with energy. So if delta E is equal to H nu, right, and this nu value it has given 300 megahertz, correct. So this nu equal to, we know that it is this gyromagnetic ratio divided by 2 pi, and here it will be applied magnetic field, correct. So do cross multiply, you will get it, H0 equal to nu into 2 pi divided by your gyromagnetic ratio. So how much it is coming, nu is your 300 into 10 to the power 6 into 2 into 3.14 divided by your gyromagnetic ratio. How much it is? 26.75 into 10 to the power 7. Okay, it's a easy calculation, simple. Okay, already I have calculated. Okay, otherwise it will take more time. So I have calculated. It will be your 70.4299 into 10 to the power, how much is coming? -1. Okay, so 10 to the power -1, it means you have to just shift it towards this place. So 7.04, I'll take it. This side do not need to take. So 7.04 Tesla, we got answer. Okay, 7.04. So 7.04. So your answer range they have given 7 to 7.10. Okay, 7.00 to 7.10. This is the answer range they have given, and you got it 7.04, right? So this will be your correct answer. So this is a numerical aptitude type, and they have asked for rounded off to the nearest integer in 2 decimal places, right? So they have called round off to 2 decimal places. So 2 decimal places we have rounded off. So 7.04. This is your answer, right? So this much only we were having from NMR. So this is with one formula we have calculated. Another formula, it is left over because they have not asked any question in that. So maybe in upcoming examination they might ask you with that formula, the delta value, right? Observe frequency distance from TMS divided by your instrument frequency multiplied by 10 to the power 6. Okay, with that they might ask what will be the delta value. Okay, or maybe they are giving delta value and they will ask the distance from this value from your TMS. Okay, what will be the like the frequency distance, correct? That maybe they are asking, they will ask. Okay, so tomorrow I will do the quantum chemistry. Okay, as many times it has requested that quantum chemistry. Okay, I'll just finish it up quantum chemistry and then directly go to the organic chemistry. Okay, so if you really like this class, please like it and share it to your friend. Okay, and ask them to subscribe. Okay, so this small help I need from you, correct? So thank you very much for watching.